Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 496. Next greater element 1. The next greater element of some element x in an array is the first greater element that is to the right of the x in the same array. You are given two distinct zero-indexed integer arrays, num1s and nums2s. Okay, where nums1 is a subset of nums2, which means it contains the only values from the nums2 in an order. Okay. Now, for each 0 to I, 0 is less than or equal to I is less than or equal to less than nums1 dot length. Find the index j where that nums1 of I is equal to nums2 of j and determine next greater element of the nums2 of j in nums2. If there is no greater element, then the answer is the -1. Okay, return an array answer of length nums1 dot length such that answer of I is the next greater element as described above. So they are asking us to find the next greater element. As you know, in this playlist I already completed this next greater element. Okay, we can do in two methods, right? Okay, in this video also I am going to say about those two methods, and we may proceed with some other techniques to solve this kind of problem. Okay, let us see the example so that it will be more clear. See here. So this is a nums1, okay, and this is a nums2. Now just observe here it is 4, right? Here it is 4. What is the next greater element of 4? See here in this nums2, I can say here is 4 and the next element is only 2, right? It's only 2. Whether 2 is greater than 4? No, no. So it cannot be an answer. There's no element. That's no element. So 4 has no greater element. So we want to what? Add our result as -1. Clear? Now 1. Now 1 is here. 1 is here, right? 3. 3 is greater than 1, right? 3 and 4 and 2. 3 are greater than 1. But the immediate next greater element is 3. 3. So I will add 3 as my answer. Clear? Now it is 2. Now go to 2. 2 is here. There is no element next to 2. There is no element next to 2. So I can write as -1. Got it? Yes. So this is all about the first example. Now let us see about the second example. So it will be more clear still. See here. Here is 2. So where's 2 here? Here's a 2. And there are two elements next to 2. Right? What are they? 3 and 4. Among that, which is the greater element? Both 3 and 4 are greater, right? Both 3 and 4 are greater. Now, just analyze which is the next greater element, which is the immediate greater element. I can say the immediate greater element is 3. So, my answer should be what? 3. Yes. And then now, take 4. 4 is here. There is no next element. Then how come there is a next greater element? So, you will return what? -1. So, 3 -1 will be my answer. So, this is the example. Now, let us see the approach. Just think about it. If we change each and every element in this array as the next greater element, then it will be more easy to find this, right? It will be subset, right? Just see here. Nums1 is subset. Subset of what? Nums2. What it signifies? It says that nums1 contains only those elements present in nums2. Okay. See here. 1, 4 and 2 are present here, but 3 is not present. So it is a subset. Nums1 is subset of nums2, means it may contain all elements, then it may contain some element, but it do not contain an element which is not present in nums2. That means the subset. Okay. So that I can say we want to find each and every next greater element of this nums2, and then we want to substitute that in nums1. It's quite simple, right? Just assume. What is the next greater element of 1? I can say next greater element of 1 is 3. Okay. Now, what is the next greater element of 3? I can say this was what? It is as 4. Yes. And then, what is the next greater element of 4? There is no greater element. So, I can say -1. I may put this arrow so that it will be more clear. Okay. Now, what is the next greater element of 2? There is no next greater, right? So, it is -1. So, this is what the next greater element for this all values, right? Now, coming to the point, now we are going to find for what? Find for nums1. But how? See here, first is 4, right? Just let me write here 4, 1, 2, right? Now, just observe, here is 4. Where is 4 here? 4. So what is the next greater element? There's no greater element, so it is minus 1. So let's put minus 1. Now where is 1? 1 is here. What is the next greater element? It is 3. So put 3 here. And 2. Where is 2? 2 is here. Put minus 1. So this is what the approach. This is what the approach, simple approach. Okay. Now how we can know this 1 means this 3. This 3 means this 4. This 4 means this minus 1. Can we use map? Can we use map? Hash map. So that it will be more, it will be taken, the values are taken much simpler by using the key, right? So that I can use what? Map. Fine. So these are our element inside my map. I will map. See here, in my map, there will be what? The keys are the element. Keys are element, whereas the value is next greater element. So this is how my map looks like. This is my structure of my map. Now it is more clear, right? Now the only thing is to find the next greater element. How to find the next greater element? Okay, let me go with the brute force approach. How to find the next greater element using a brute force approach. Brute force. Okay, just see here. There's a elements like 1, 4, 3, 2. Okay. Now, what's the next greater element of 1? How can I find it? I can say, just remember, for this 1, I can say, I want to traverse through this 4, 3, and then 2. Yes. And then I want to check whether there is a greater element occurs as first. Okay, let me check this 4. 4 is greater than 1. Yes, it is greater. So I can put what? 4 as my output for 1. Okay, now take this 4. Let me change the color. Take this 4 and check towards the right side. So whether 3 is greater than 4? No. Whether 2 is greater than 4? No. Whether any element present here? No. So 4 has no greater element. So what is the answer? It will be minus 1. Fine. Now again take for 3. So now we are taking 3. Let me change the color. 3. For 3 we are going to check towards the right side and 2. Whether 2 is greater than 3? No. Whether there's element, no elements. So for 3 it is minus 1. And then for 2 there is no element, so it's also minus 1. Clear. This is a brute force approach. So what is the time complexity? It is O of n square, the time complexity. And then the space complexity will be O of 1 because there is no auxiliary space, right? So this is the approach number 1. Finish, right? Now can we optimize it? Okay, just observe here. For this 1 we are taking the immediate next greater element. So I can say if I use stack so that the previous element are stored in that stack, I can take it, right? I can take it. Okay, but how we can take it? I give you an example. See here, 1, 4, 3, 5. Let me take this another example. Okay, now take a stack here. This is a stack. Now tell me, first I have to traverse this way or I have to traverse this way. For simplicity, I will traverse this way because the next greater element represent where? Represent from right. If I want to find the next greater element 4, we want to traverse towards the right. So if we know the greater element among right, we can easily find out for this 4 right. If you don't know, don't worry. By using this method, it will be more clear. Right. Just see here for this 5. Okay, whether stack is empty? Yes, stack is empty. So don't worry. Just directly put it. So second method, just directly put minus 1 for that. Yes, because the stack is empty, right? The stack is empty. Okay. Now again, put this 5 here. Put this 5 inside the stack. Okay. Now again, this 3. The stack is empty. No, stack is not empty. Okay. What are the stack elements? Stack element is 5. 5 is greater than 3, right? So it will be my part of my answer. It is my answer, right? Why it is my answer? Because 5 is the greater element which is immediate next to 3. That's why it remains at the top of my stack. My top is 5, right? So 3. So 3 is less than 5. So that I can say this 5 is the next greater element of 3. So I will put this 5 here. Finish. Now put this 3 here. Okay. Now take this 4. Now check whether stack is empty. No. What is stack top? Stack top is 3. Yes. But 4 is greater than 3, right? Then how come this 3 can be my next greater element of 4? No. So I will pop it out. I will pop it out. Just pop out. Fine. Now again check for stack top. Now stack top is what? 5. But 5 is greater than 4. 5 is greater than 4. So 5 should be my next greater element. 5 should make next greater element. So put 5 here. Finish. Now update this 4 here. Yes. Now again go for 1. The stack is empty. No. What is stack top? Stack top is 4. So 4 is what? Greater than 1. So 4 will be my answer for next greater element of 1, right? So put 4 here. Put 4 here. Okay. Fine. Now add this 1 here. Then check here. There is no element. So just stop it. Now what is the answer? 4, 5, 5 minus 1. Got it? Got it? Some of the mistakes done in this approach is we don't traverse from while traversing from right to left, they will forgot to add at the right position. For this 5, what is the index here? 0, 1, 2, 3. Instead of adding to 3, they will append so that it will go for the 0 to index. The array will be reversed. Okay, this is a common mistake we have done. Okay, I made personally like I just appended every value instead of inserting at the right index. So insert at the right index. Insert at right index. So this is the mistake I have made in this stack approach. Okay, that's all. Now, what's the time complexity of this approach? I can say the time complexity of this approach is O of n, because we are traversing only one time this whole array, and then if we push one element inside the stack, we will pop it once, right? It won't be repeated, so that plus n. So overall it is O of n. And then what is space complexity? It is O of n, because we are using auxiliary space stack. There may be a worst case where stack will be full of n elements, so that my time complexity and space complexity are what? O of n. Okay, fine. Now just combine these two methods, like the stack method and then the dictionary method, so that we will find the next greater element for each and every element in nums2. Now we will substitute that elements inside the nums1. That's all. Okay, let me show the code now so that it will be more clear. So, and finally, this is the approach, stack approach to find next greater element. This is the time complexity for next greater element. But overall time complexity of this code, this program will be what? We are using extra dictionary, so space will be plus n, but it will be overall O of n. But time complexity is what? O of n log n, because we are inserting towards the inserting inside the dictionary and we are taking out from the dictionary. So it is what? N log n. Right? Now let us see the code now. Just see here. D is equal to map. Okay. I am just initializing a map. Now stack is equal to empty list. Now result is equal to empty list. Now for I in range of len of nums2 minus 1 minus 1 minus 1. I am just traversing from where? From right towards the left. Okay. 0 to this. Now while stack, if stack is not empty and stack minus 1 is less than nums2 of I, which means if there exists a stack, and also a stack top is less than or equal to, I forgot to put equal to, okay, is less than or equal to nums2 of I. Okay, that means see here, if it is 3, but the current element is 4, we want to remove this 3 because it won't be the answer. That's why I input the less than or equal to symbol. Okay, then I want to what operation I want to do? I want to pop that value from the stack. If not the stack, if there is no stack at the end of this operation, after running this whole loop, then what should I do? I should do what? I want to map that element with -1. Okay, fine. I want to map with -1. Now d of nums2 of I is equal to stack of -1. Okay, because if there exists stack, then I want to map with the stack top element, right? Because that is the answer for the next greater element. Now stack dot append of that nums2 of I. We are just appending that stack with the current element, right? Now, for I in nums1, result dot append of t of I, which means for each and every element for this 4, this 4, we are just appending the value of that dictionary key called 4. Okay, can you understand this? See here, let me print this dictionary so that it will be more clear. Print d. Yes, see here, 2 minus 1, 4 minus 1, 3 4, 1 3. It is a dictionary created by the this process, right? For nums2, this is the nums2 element corresponding to the next grade element. Now we are just what, finding the value by using this dictionary and appending to the answer. That's it. Fine. And then here, if we don't put this equal to, it is correct for this problem. Why? Why? Because here are all are distinct integers. All are distinct integers. So if we don't put this equal to, it is okay. But still putting equal to is a good practice, because while there is a next grade element with duplicate elements, then if a stack top is 5 and the current element is also 5, we want to pop this element. We want to pop this element. Okay, but if we don't put this equal to, it won't pop this element. Just put the 5 as my answer. Okay, so this is what a common mistake doing. We all do in the what normal next grade element problems. Okay, but still here we don't want to put this equal symbol. Right? Let me submit it. Yes, it is submitted successfully. Hope you understand this problem. Thank you.